Hello there, this is Rashmi. Here I am with a video on electric lines of force. What does it mean? Electric lines of force means it is an imaginary smooth curve drawn in an electric field around which a free isolated positive charge moves. That means if you place a charge of unit magnitude in an electric field and if this charge is free to move, what will happen? It will trace a curve in an electric field. It may be a curve, it may be a straight line. So this curve, this line is an imaginary one and it is only known as electric lines of force. Now let us see more vividly what does it mean. Suppose you have a point charge Q. And around it you bring a charge of unit magnitude. Now this charge of unit magnitude will feel a force due to this point charge, and if it is free to move, it will try to move in a particular direction. So in this case, suppose if it is a unit magnitude, this charge will affect the force of repulsion, and since this is a point charge, this charge of unit magnitude will feel a force along the radius. So if you see it, if a number of point charges are placed in these places, it all will feel a force of repulsion. Okay, and all these lines will be directed towards the radius since it is a point charge. It creates an electric field around it, and in this electric field, if you bring a unit positive charge, it will move tracing an imaginary line or a curve. Now it is not necessary that every time it should be along the radius. Only in this case, since it is a point charge, it is in this radial form. Now these lines are imaginary, and when this is a single charge, this is a single point charge, you see, and that's why this line will go up to infinity. We don't know where these lines will go and end. So for a single charge, it goes up to infinity, but for two type of charges, we will see the case is little bit different. And before we move on to the different cases, we should at first know the characteristics of electric line of force. So let us see first what are the characteristics of this electric line of force. So the electric lines of force are given in this manner. Let us see the first point. The lines of force are continuous smooth curves having no breaks. What does it mean? It means that the line are continuous. Once it starts from a source charge, it will keep on moving. There are no breaks. Okay, there are no breaks. There are no breaks like this. It is continuous in manner. Okay. Next point, it says that the tangent drawn at any point on the line of force gives the direction of electric field at that point. Now, what is the meaning of this statement? Suppose this is the imaginary line, or this is the line of force. So suppose you want to find out the electric field. We are discussing about electric line of force. Now the question is where to find the electric field due to a particular charge. So the electric field at a particular point is given by drawing a tangent along that point. If this point is A, the tangent at this point will give the direction of electric field at this point. Now if you consider the point like this, so tangent drawn on the curve will give you a direction of the electric field at that point. Okay, so the meaning of this line is this. The third point says that the lines of force originate on the positive charges and terminate on the negative charges. So the meaning of this we will see after some time. What is the meaning of this statement? It will be clear after some time when we will draw the electric lines of force for different charge distributions. The fourth point says that no two electric lines of force can cross each other. What does it mean? Suppose you have this line of force and suppose you have this line of force. Now you want to find out the electric field at this point. Now the electric field at this point due to this line of force will be along this direction, and the electric field due to this line of force will be along this direction. So now you see from a single point you have two directions of electric field. So at a particular point you cannot have two directions of electric field. We can have only one direction of electric field. So it is said that no two electric lines of force can cross each other. Okay. So the next point says the relative closeness of the electric lines of force indicates the relative strength of the electric field in any region. What does it mean? It means that suppose in a region the electric field lines are very close. Okay. Electric field lines, in another region the electric field lines the electric lines of force are very far apart. So this indicates that this region has a stronger electric field compared to this region where the lines are farther apart. This concept will be more clear when we see how electric field lines can be drawn around various charge systems. Okay, but you should remember this, that when they are nearer to each other, the lines of force, electric field is strong, and when they are farther apart, the electric field is weaker with respect to this one. Now, the electric lines of force do not pass through a conductor. So we have to remember the electric field line do not pass through a conductor because inside the conductor, the electric field is equal to 0. So that's why we are unable to see any line of force inside a conductor. Now we will see how to draw electric lines of force for different type of charge systems. Let us see now how to draw electric lines of force around different charge systems. So first let us see how to draw electric lines of force around a positive point charge. For this we will take a point charge at the center. So let us take a plus point charge. That is, the point charge is of positive magnitude, and imagine there is a unit magnitude somewhere here. Unit magnitude positive charge somewhere here. So it will feel a force along this direction. So if it is somewhere here, it will feel a force along this direction. If it is here, it will feel along this direction. That means along the radius. Along the radius, it will feel forces along all these directions, and hence electric field lines of force can be represented by these lines. Similarly, in case of a negative point charge, what will happen? If you imagine there is a charge of unit magnitude somewhere here, it will feel a force along this direction. That is, since it is positive magnitude, it will feel a force of attraction along this direction, that is towards the negative charge. So if the point is here, if the unit magnitude charge is here, it will be attracted in this direction. If it is somewhere here, it will be attracted in this direction. If it is somewhere here, it will feel a force of attraction along this direction. Hence, all will be along the radius and towards the negative charge. Now, as I discussed earlier, that since these are single charges, these lines of force will extend up to infinity. Okay. So now for the case of two equal and positive charges, what will happen? Suppose these are positive charges, positive point charges. So the lines of force will have a tendency of contracting. These are the lines of force So that is, these both the charges are creating a force of repulsion. And when the charges are like, the lines of force have a tendency to expand laterally. Okay, so that's why it will be in all these directions. So if these are along these directions, there will be a point at the center of these two charges where this point will be known as a neutral point. That is, here there is no electric field. The electric field means due to both these charges, the mutual field get cancelled, and here there is a point where there is no field. And suppose if there is one negative charge and one positive charge, what will happen? So in this case also, we will see the line are represented along these directions, but here what will happen, the lines will be represented in this manner because there is a mutual force of attraction. There will be a force of attraction, and the arrow should be along this direction because we know that for a negative point charge, the arrow should be towards the charge, and for a positive point charge, the arrow should be away from it. So we can represent in this manner. These are the line arrow will be along this direction. So when the charges are unlike, the lines of force have a tendency to contract lengthwise. So you see all the lines of force are getting contracted along the length. So these are also will contract at a further distance. These will also contract at a further distance. So you see the lines are getting contracted. And another thing, here you see the lines, the electric field lines of force. The lines of force are starting from the positive charge and ending at the negative charge. So we had discussed in one of the points that the lines of force always starts at the positive charge and ends at the negative charge. So here we can easily see that this is happening. Okay. So this is our diagram for electric lines of force. There is one more. So that is electric lines of force for a positively charged conductor, plane conductor. So this is the fifth case, the positively charged plane conductor. In this case, how will the electric lines of force be represented? So if this is a plane conductor positively charged, if you imagine there is a unit charge here, unit positive charge here, so it will be, the electric lines of force will be along this direction. If you imagine here, all will be along this direction. It will be straight and equidistant from each other. That is, in uniform pattern, it will, the electric lines of force will be represented, and the arrow will be along this direction, because you know, if unit positive, if you imagine a free unit positive charge here and this is also positive, so this will experience a force of repulsion. Now if you consider a unit positive charge along this direction, it will experience a force again along this line, and it will be again directed along this direction. So this was all about electric lines of force. So always remember, we have to draw electric lines of force imagining that a free positive charge is kept near a source charge, or in an electric field it is kept, and the line that it will trace will represent the electric lines of force. Okay, that's all for today. Thank you.